Question 1. How are ammeters connected to a circuit? Are they in series with the resistor they measure? In parallel with the resistor they measure? In series with the power source? Or in parallel with the power source? The answer here, of course, is A. They are in series with the resistor they measure. Ammeters measure current, and if they're in series with a particular resistor, then the same current will flow through the resistor and the ammeter. Question 2. How are voltmeters connected to a circuit? Is it in series with the resistor they measure, the same as ammeters? Is it in parallel with the resistor they measure? Is it in series with the power source? Or is it in parallel with the power source? Now I hope that you can see that the answer over here is going to be B. The voltmeter is connected in parallel with the resistor they measure. Voltmeters measure potential difference, voltage, that's why they're called voltmeters, and they do this by measuring the potential difference across themselves. If they're wired in parallel with a resistor, then the voltage drop across the voltmeter will be the same as the voltage drop across the resistor. Of course, if we wanted to measure the current being drawn from the power source, or the voltage of the power source itself, then we could connect the ammeter or the voltmeter in series to or in parallel with the power source. Question 3. What would happen if an ammeter was connected in parallel with a resistor? Remember that this isn't what we're meant to do. We're meant to connect ammeters in series. Now, we know that an ammeter has very, very little electrical resistance, just like a wire. So we can think about this circuit in the same way as we can think about a circuit like this. Here we have a resistor, and here we have a wire. So this is where the ammeter is. Now, what will happen when current flows through here out of the power source? Well, we know that when current flows through a parallel circuit like this, more current will go down the branch with less resistance. The thing is, the top branch of the circuit has almost no resistance, because ammeters have almost no resistance. And that means that we pretty much completely stop the flow of current through the resistor and have all of the current flowing through the ammeter. And of course, the ammeter will draw far more electric current than the resistor will. The ammeter's extremely low electrical resistance would cause all of the electric current to flow to the ammeter's branch of the circuit instead of the resistor's branch. And that means that we're changing the circuit quite dramatically. What would happen if a voltmeter was connected in series with a resistor? Remember once again that we're meant to connect voltmeters in a different way. We're meant to connect them in parallel. So if we connect it in series with a resistor, what would happen? The electrical circuit would look something like this. We have a power source, a resistor, and then we have a voltmeter. Now the thing about the voltmeter is that its resistance is almost infinite, right? It's going to be very, very large. So we can think of this resistor as just a gap in the circuit, because a gap in the circuit has a very large resistance as well. So what will happen when current tries to flow through this? Well, nothing. The circuit's broken. Or rather, the circuit has such a high resistance that no current can flow at all. So the voltmeter's extremely high resistance would prevent current flowing through both itself and the resistor that it is in series with. Remember that when one particular electric component is in series with another, then the same current always flows through them. Question 4. Predict the current flowing through both ammeters, A1 and A2, and both 100 ohm resistors, R1 and R2. So both R1 and R2 have a resistance of exactly 100 ohms, right? So let's take a look at this. We have R1 and A2 in series with one another, and the pair of circuit components, R2 and A1, in parallel with each other, and that pair is in series with the others. Now, what happens when, like in this case, we have an ammeter in parallel with a resistor? Well, what it means is that when the electrical current gets to this branch, almost no electrical current will flow through R2, right? Because the ammeter has almost no resistance. So the electric current will preferentially go through A1, and current will continue flowing like that. So it means that we get no current flowing through R2. Now, the others, R1, A1, and A2, if we ignore R2 altogether, then we now just have a very simple series circuit, so the same current must flow through each of these. For A1, it'll be ever so slightly smaller, but so close to the same that we can treat it as the same. The total resistance of the circuit is just the resistance of R1, that is, 100 ohms. So if the voltage is 10 volts and the resistance is 100 ohms, then the current must be 0.1 amps. So A1 has 0.1 amps, A2 also has 0.1 amps, R1 has 0.1 amps, but R2, because it's in parallel with the ammeter, gets all of the current that would flow through it sucked out by A1. So R2 has no current flowing through it. Question 5. It is possible to use equations to predict the current and voltage through a resistor based on its marked resistance without using ammeters or voltmeters. But when we do experiments in the lab, we still use ammeters and voltmeters, and we still make these measurements even though we could just calculate them all, right? So why do we do this? Well, the reason is twofold. One reason is that often we're doing experiments where we don't know how changing the circuit will affect the voltage or the current through a particular resistor. But there's another reason as well. The markings on the resistor and the markings on the power source are not guaranteed to be accurate. They might be off by a bit. The ammeter and the voltmeter will produce an independent measurement, a measurement of the resistor's resistance that is not dependent on the writing on the resistor itself. And this will be able to improve the accuracy of the experiment. So, that's the end of the questions. In this section, we've learned about ammeters, which measure electric current, and voltmeters, which measure voltage. We've learned to connect ammeters in series with resistors, and voltmeters in parallel with resistors.